Welcome to our presentation of Toms River and Flint River, the parallels of water contamination. This presentation was a collaboration by Kimberly Gilbert, Chelsea Miller, and Vicki Eber. The situation in Toms River began with the company Ciba-Geigy establishing a plant there. From 1952 to 1986, Ciba-Geigy used the Toms River site for the manufacturing of dyes and pigments. This site was also used from 1959 to 1991 for manufacturing plastics and additives. The wastewater produced by the manufacture of these products was released via pipeline directly into the Toms River from 1952 through 1966. In 1966, Ciba-Geigy constructed a 10-mile underground pipeline to empty the wastewater directly into the Atlantic Ocean. In addition to the disposal of the wastewater, an estimated 35,000 drums of waste were buried in an unlined landfill site at the plant. This landfill took up 1,400 acres in size. Roughly another 30 acres of the plant was used for the disposal of industrial solvents and other chemicals. These substances were dumped directly onto the ground and into wastewater treatment lagoons. In the Toms River case study, vulnerable populations include the economically disadvantaged, racial and ethnic minorities, the underinsured, low-income children, the elderly, the homeless, those with human immunodeficiency virus, HIV, and those with other chronic health conditions, including severe mental illness. In the case of Toms River, it is far from affluent, with tourism and egg farming being its two major industries. In this travesty, a startlingly large number of children, one of the most vulnerable populations in Toms River, were stricken with cancer, especially leukemia and tumors of the brain and nervous system. Eventually, some of the town's citizens became suspicious that the cancer cluster among their town's children might be linked to pollution from the Ciba-Geigy plant. The chemicals involved in the Toms River contamination include trichloroethylene, tetrachloroethylene, benzene, and chloroform. All of these substances are known or suspected to be carcinogens. Trichloroethylene vapor is readily absorbed from the lungs, and inhalation is the main route of exposure. It is heavier than air and may cause asphyxiation in poorly ventilated or enclosed spaces and in low-lying areas. It has wide use as a metal degreasing agent. It is a common ingredient in cleaning agents, paints, adhesives, varnishes, and inks. Tetrachloroethylene is a manufactured chemical that is widely used for dry cleaning of fabrics and for metal degreasing. It is also used to make other chemicals and is used in some consumer products. It is made by direct chlorination or oxychlorination of certain hydrocarbons. It is used as a chemical intermediate, as a solvent for metal cleaning and vapor degreasing, and for dry cleaning and textile processing. It is found in many household products, including paint removers, water repellents, silicone lubricants, spot removers, adhesives, wood cleaners, and many products used by hobbyists. The major sources of benzene exposure are tobacco smoke, automobile service stations, exhaust from motor vehicles, and industrial emissions. Vapors or gases from products that contain benzenes, such as glues, paints, furniture wax, and detergents, can also be a source of exposure. Additionally, leakage from underground gasoline storage tanks and from landfills or hazardous waste sites that contain benzene can result in benzene contamination of well water. Chloroform evaporates very quickly when exposed to air. It also dissolves easily in water and does not stick to the soil very well. This means that it can travel down through soil to groundwater, where it can enter a water supply. Chloroform lasts for a long time in both the air and groundwater. Most chloroform in the air eventually breaks down, but this process is slow. Trichloroethylene is absorbed through intact skin, although usually not in quantities sufficient for causing systemic toxicity. Children are more vulnerable to this toxicant due to their larger surface area, i.e. body weight ratio. Tetrachloroethylene is often found to have entered the body through inhalation, the most important route of exposure, and is readily absorbed through the lungs. Exposure of high levels of tetrachloroethylene vapor causes ocular irritation. If ingested, tetrachloroethylene is rapidly absorbed and can cause systemic effects similar to those seen with inhalation exposure. Benzene can enter your body through your lungs, gastrointestinal tract, and across your skin. When you're exposed to high levels of benzene in air, about half of the benzene you breathe in passes through the lining of your lungs and enters your bloodstream. When you're exposed to benzene in food and drink, most of the benzene you take in by mouth passes through the lining of your gastrointestinal tract and enters your bloodstream. Chloroform can enter your body if you breathe air, eat food, or drink water that contains chloroform. It easily enters your body through skin as well. Therefore, chloroform may enter your body if you take a shower or a bath in water containing chloroform. In addition, you can breathe in chloroform if the shower water is hot enough for chloroform to evaporate. Both trichloroethylene and tetrachloroethylene can cause respiratory and central nervous system depression and abnormal heart rhythm. In addition, it can also cause liver toxicity and renal failure. These volatile chemicals are known or suspected carcinogens. Long-term exposure to benzene can cause cancer of the blood-forming organs. This condition is called leukemia. Exposure to benzene has been associated with the development of a particular type of leukemia called acute myeloid leukemia, AML. The Department of Health and Human Services has determined that benzene is a known carcinogen. Chloroform affects the central nervous system, brain, liver, and kidneys after a person breathes air or drinks liquids that contain large amounts of chloroform. Over long periods of time, chloroform may damage your liver and kidneys. Large amounts of chloroform can also cause sores when the chloroform touches your skin. When we consider the time period of the Toms River contamination event, it's important to remember that the EPA was in its infancy, having just been formed in December of 1970. The environment was just coming to public attention. However, despite these two facts, the situation in Toms River could have been prevented in the following ways: through safety and environmental inspections of the Ciba-Geigy facility and grounds, through inspections of their waste management storage pits and disposal processes, through water quality tests of the Toms River and the public wells, through water quality tests both pre- and post-treatment of the water treated at the Ciba-Geigy facility, and soil samples from the river banks and marsh areas downstream. Ciba-Geigy was known for being innovative in their industry. As such, they produced quality commercial products at an affordable industry price. But it came at a cost. In order to stay innovative, Ciba-Geigy utilized illegal dumping, pollution, and shady business practices. Ciba-Geigy released contaminated wastewater into the Toms River until 1966. After that, a pipeline was built leading directly to the Atlantic Ocean. Additionally, 35,000 drums were dumped onto the ground and into the wastewater treatment lagoons, which led to the waste seeping into the aquifer, which eventually runs into the Toms River. Ciba-Geigy wasn't the only company using the Toms River area for questionable environmental practices. Union Carbide Corp. Is responsible for the contamination at Reich Farm, where 4,500 drums of hazardous waste were deposited in 1971, infecting first the groundwater and then the Parkway well field. While the government is to be commended for responding to citizen requests and taking action against Ciba-Geigy, as well as declaring the Ciba-Geigy and Reich Farm sites as Superfund sites and continuing to monitor for pollution levels, it must also be said that their delayed response to concerns from the general public, their downplaying of the seriousness of the situation, and lack of concern for the environment have made the Toms River situation into what it is today. The Flint River crisis began in 2012. The City of Flint and the State of Michigan conducted water research and determined that the city needed to move from Detroit Water and Sewage to the running of their own water line connected to the Karengondi Water Authority, KWA. In the spring of 2014, while the water line was being built, the Flint River was used as an interim water source following the disconnection from the Detroit system. The river water went untreated in order to ensure corrosion would not occur. However, in late summer 2014, E. coli and chloroform were found in water analysis tests done on the Flint River. By fall of 2014, GM, who had been born in Flint, Michigan in 1908, stopped using the Flint River water due to concerns of corrosion in their own equipment. They began getting water from neighboring Flint Township. Water tests of the water in Flint found that high levels of trichloromethanes, TTHM, and lead were discovered in the water. Levels of lead were found to exceed the federal action level of 15 parts per billion. In some cases, the level was 7 times that high. By 2016, a state of emergency had been declared for Flint. With regards to the Flint River case study, the entire population of Flint was susceptible, largely consisting of poverty-level residents as well as racial and ethnic minorities. However, the main focus of research has been on the blood lead levels in the children of Flint, Michigan, in comparison to those children in the surrounding cities and towns encompassing Flint. Data was collected anonymously via the Michigan Department of Community Health. According to Abelson and Sanborn, children are more susceptible to lead poisoning, mainly due to the amount of oral contact they make to objects. However, they are also more susceptible due to the absorption rate through the gastrointestinal tract, which can impact their underdeveloped blood-brain barrier. These factors alone make the children of Flint the most susceptible population. even with all persons who have drank or bathed in the contaminated water being highly susceptible to lead poisoning. Pregnancies would also be considered higher risk, as the fetus can be detrimentally impacted by high lead levels. Water analysis on the Flint River found increased levels of lead and trihalomethanes. Trihalomethanes are a result of chlorine or bromine treatments interacting with organic matter in the same water source. This is considered to be a disinfecting byproduct due to this reaction of chemical and organic materials coming into contact with one another. This is found in water that has been treated with chlorine or bromine. Lead exposure is also commonly found in water, air, soil, and dust particles. In the case of Flint, the corrosion of the lead pipes in the water system caused the contamination of lead in the drinking water for Flint residents. Other sources of lead contamination can come from old lead-based paints and residues of those paints, such as dust inhalation from renovation of homes, as well as occupational exposure to lead. In the case of the citizens of Flint, Michigan, lead and trihalomethanes were ingested via drinking water and absorbed through the skin by bathing in the same water source. Increased levels of trihalomethanes can cause a depression in neurological functioning and liver damage. Lead toxicity is more severe as it impacts every organ in the body. The mechanisms for action for lead toxicity are disruption of ion homeostasis and transport, protein binding, oxidative stress, and inflammation, common to cells for every organ system. Neurological impacts of lead toxicity impact children the most, as it can hinder the development of behavioral and cognitive abilities. Lead toxicity also impairs the immune system, decreases blood hemoglobin and anemia, increases blood pressure and risks of hypertension and cardiovascular disease, causes impaired kidney function, and decreased fertility. It also degenerates and decreases function of major organs such as respiration, enlarged liver, bone loss and deterioration, ocular function, and increasing the risk of cancer. Fetal development during pregnancy is also impacted, with lower birth weights and delay in puberty onset for both male and female children. Preventative efforts should have been in place to routinely check the pipelines carrying drinking water to the residents of Flint, Michigan. Another option to prevent the overexposure of lead and copper to these residents would have been to replace the lead pipes. At the time, it was known that lead could pose a danger to the health of humans, knowing corrosion was a possibility. Routine checks of the water would also have taken larger preventative measures, rather than waiting for the residents to find rusty and foul-smelling water coming out of their taps, as was the case, which would imply that corrosion had been happening for a while to lead to rust developing. When considering the actions of those responsible for the pollution and the government's actions, these two are one and the same, as the government was responsible for deciding where the residents of Flint would be accessing their water, therefore having responsibility for the health of the water. While they are commended for providing free water filters and bottled water to residents affected by the Flint water crisis, funding for infrastructure improvements such as changing out the pipes and prosecuting government officials involved in the cover-up, and starting the investigation over due to improper evidence collection, it should also be noted that their delayed action against the corrosion and lead levels, the lack of funding given to fix the problem throughout the process, the cancellation of beneficial products such as bottled water and water filters, and starting the investigation over, leave a lack of responsibility for their actions. In both this slide and the next, you will find the many sources that we used for information on both Toms River and Flint River. These sources conclude our presentation.